Hi, I'm Harri Tapio from Koru. I will be giving a brief introduction to how applications are built with Koru. We will be looking into how the application views are defined and how we actually implement the logic for the application itself. We are also going to look briefly at the file structure of a typical application, and in the end, hopefully, we will have a working music player application with nice visuals. So first things first, what you are seeing here on my screen on the left-hand side is VS Code. So this is my editor of choice. And since all Koru files are text, you can use your editor of choice. The reason why I'm using VS Code is my personal preference, but we also have extensions built for VS Code that help you with the development. We have things like syntax checking and auto-completion. On the right side of my screen, you can see the application already running, so the window with the blue background. In my editor, we can actually see the file structure of this application. So the interesting part is these 4 files over here. So the main view in this application, we only have a single view. It defines the content on the screen. So the view files, similar to HTML files online, basically define the content and the structure of the view. Then we have a Stylesheet file, so the CSS file. And again, this is similar to HTML and CSS online. So this is the style sheet. So what the view contents actually look like. And the reason why we want to use a file for styles instead of just defining those inline in the view itself is because we then get the flexibility of applying different style sheets or different styles depending on the display aspect ratio, display size, and so on. So since we can easily swap out the style sheet, it means that we don't have to change a single line of code or the view contents themselves if we simply want to change how the view looks like. This allows easy theming and adjusting to different aspect ratios or display sizes and so on. Then we have the widget definition file. This contains pre-existing components done by Koru, which means that you don't have to build your own components for typically when you are building an application. We provide a large collection of ready-made UI components such as push buttons, checkboxes, scroll views, and other more elaborate widgets that do, let's say, rotate the analog clock hands without you having to write a single line of code. And the 4th file that is of interest here is the JS file. So this is the JavaScript file, and in this application we only have one JavaScript file for the music player. So that is the brief introduction to what Koru is and what is a typical structure for a project. So next, let's start looking into what actually goes into these files. So I already have my main view open here. And the main view content at the moment is simply a link to the JavaScript file that will be executed when this view is loaded. We also have a rectangle with a specific class from the style sheet applied. Then we have a text element with the text buffer hello. And you can see the view content here in my actual application that is running. One of the nice features with Koru is that whenever you make changes, you don't have to compile or wait. If I make a change and I save, you can immediately see the change being applied here. So, like I mentioned, the view itself defines what content you have in the view. Typically, we don't define what the content looks like that's left for the style sheet. But the style sheet is optional. We could also define the exact layout with inline attributes in the element themselves. So in this case, for the text buffer, we are defining a white fill and anchoring the text to the center of the display. In the case of the rectangle, we are applying a style from the style sheet, and we are applying a hello fill. So let's look at the style sheet, which is optional, but which we are using in this case. So looks like we have two different styles here. The hello fill is defined, and we are defining a Koru blue. So any element with a class of hello fill will get a blue fill color, and that's the reason the rectangle is blue. You can also have multiple classes and styles applied to a single element. We also define for all the text elements a font size of 48, which is the reason why the text appears at 48 pixels. Then we have gone through the view file, the content of the application or the view, the style sheet, the actual styles being applied to the elements on the view, and then last we are going to look at the application logic. So in the main view we are linking this JavaScript file. If we look at the contents of that file, at the moment it is empty. So we have the view callback, which basically is a callback to anything happening in this specific view. So we can catch events from the elements and widgets on the view. And like I mentioned, the nice thing about Koru is that whenever you are making changes, if you save, you don't have to compile. You will see those changes applied immediately. So in this case, let's add a console log to our preload event. The preload event happens when the view is basically launched. The contents have not yet loaded, but we are getting the initial event for preload. So if I remove the comments from this file and I save, we should be able to see in my terminal window the console log hello. And now we have verified that it does indeed appear, so it looks like our main view has some logic being applied. So now we have our basic application structure in place. We have the main view with some placeholder content. We have a style sheet with some styles being applied to the content of the view. And then we have the actual application logic itself. At the moment it doesn't do much, but in the next step we will be looking into adding something else. So next, let's start making this look a bit more like a music player. So let's remove the placeholder content for now and add an album artwork image here. So you can see our helper assisting me here. And let's pick an image from this directory. And now that I press save, we should have an album artwork visible. And that's it. Then let's remove some of these styles that we won't be using anymore and start adding more content. So we have the album artwork now in place, but let's add the actual music playback buttons. So this is, to save time, I'm going to be pasting them here. So these are the music playback controls themselves. We have a button to go backwards, we have a play pause button, and then we have a forward button. So we are using a music control ready-made widget, which is a component that I have created. We won't go into those details yet because of the limited time. So let's look at how the buttons themselves are defined and work. So we need to define some IDs so that we can catch the events coming from these components in the application callback. And also it makes it easy if from the application logic we want to find these elements and do something with them. So the buttons themselves have some styles applied to them. All of them apply a music control style and a foreground fill style. And then we also apply left, middle, and right. So let's look at building these in the style sheet, because at the moment if I save, nothing really happens because these components are in the view, but they don't really have a definition of what they look like. We could define the attributes here in the view, but let's do it in the style sheet to make this more representative to how actual applications are built with Koru and also how they are done on the web. So in the style sheet, what we need to do is add some styles. So let's start off by creating a couple of fill colors. So we applied a foreground fill style to all the buttons. So let's define it here. And let's also define a background fill so that we can use that later. So let's use a high contrast option of using white on a black background. Then we need to define the music control look and feel. So let's define that all the elements with the music control style are 88 pixels high and 88 pixels wide. We also define that whenever there's a left style inside a music control, let's set the position to be at 25% minus 44 pixels. So we can do basic calculations of positions, and this way we are actually dividing the 88 by 2 so that we have this button at roughly at roughly the correct place. And then the buttons need some images. So let's add the images to the buttons as well. So for the button that has the ID, this is again a CSS selector. So the button with the ID backward button, let's set the image to be the backward PNG from the images directory. And for the play pause button, we will do a similar thing. Let's use the play PNG image, and the forward button, the forward PNG image. So we added the buttons to the view, and we have some class definitions here, and we have defined those styles in the style sheet. So we should see some buttons appear on the screen when I now press save. And that seems to happen. Let's see if we can click those buttons. Yes, that seems to work perfectly. So at the moment we don't have any logic applied to these buttons. So let's start looking into the JavaScript part to actually hook these buttons up and make something happen when you press them. On the JavaScript side, I pasted some example music library content. So we have album artwork, the track names, and so on for the music itself. I also pasted the music player state used by the music player engine itself, and then added a music player which provides us with a bunch of methods for going to the next song, previous, playing, pausing, getting the duration of the track, and so on. So we will be using this to actually handle the music playback. But since this is about creating the UI and hooking it up, we won't be going into details how the actual music player works. I think it is sufficient to say that we will simply be connecting our UI components to the playback engine itself. So the next thing to do is to add the buttons themselves. So let's add them here. So we have the forward button, backward button, and play pause button, which are here on the UI. And in the view callback, let's handle those buttons. So whenever there's a load event with a specific ID, like the play pause button, we are calling the play pause button load. The other buttons work in a similar way. So let's now take a look at the forward button, for example. So when the button load is handled, it basically saves the UI component reference to the widget, and it adds an event listener for click events. So whenever the buttons are clicked, we will be handling that with the forward button click. And in the forward button click, we are actually asking the music player to go forward. The backward button is a similar case, but instead we are moving backwards when being clicked. The play pause button is slightly more difficult because it has a state, so it either needs to show the play icon or the pause icon. So in order to be notified of this, in the load, we are again saving the widget and adding an event listener for click, but we are also adding ourselves as an observer to the music player. So we will be notified whenever the music player state changes, which means that the play pause button can then react accordingly. So for click, we are simply checking the music player state. If it is play, then we are requesting pause. If it isn't playing, then we request play. In the change handling, so whenever the music engine itself is notifying us of a change, what we need to do is update the button. So the button will take care of itself whenever the music player is notifying that something has changed. So in this case, we are checking if the state has remained the same. If it has, there's no need to do really anything. If the button state is now play, then we are setting the image to the button to be the pause, because the following action will be pausing the music. And if it isn't play, then we are setting the image as play, because the following click will trigger play. So now we have our buttons added to the UI. Now what we can do is check if this actually works. So let's check if the images are being changed when we click the button. That seems to be the case. So now we know that our UI components are working in both directions, meaning that whenever we click, we are handling that click event, and whenever there's a change in the playback, we are setting the UI state accordingly. Next, we will be adding content on top of the album art. A music player needs to have the track name, the artist name, the time running, a progress bar, and so on. So we will be adding those. Due to the limited time, I will be again pasting more content. So we will be replacing the content that we had with something else. So we still have the buttons over here, but the buttons now live inside a container, and in the container we have several UI elements, which I will be explaining. So now that I saved, you can actually see the changes coming alive on the screen. So let's go through what we actually added. So we added an overlay, which is a full-size container. We added a rectangle to work as a transparent background for the top. Then we added the track and artist information, the artist name and track name texts over here. We added the track time, which is shown at the top. Then we also added a gradient rectangle, which is the background for the buttons themselves. We have our buttons from the previous step, and we also added a progress bar, which is shown here. Currently, it hasn't moved yet. So the next step we need to do is hook up the application logic to actually make all this work. In the JavaScript, we have added the overlay, and it is slightly more complicated because it has so many elements that we need to update. But let's take a look at the content. So again, on load, we are saving the view and the widget, and we are adding an observer so that the overlay is getting notified whenever the music player engine changes state. Whenever the state changes, the component will be reacting. So we will detect the track change, If the track has changed, we will be resetting the counter or the timer, and we will also be calling the update progress UI, which updates the timers and the progress bar. So let's look at what happens with the update progress UI. The update progress UI is slightly different to how other updates were previously done, because these are Koru widgets that have specific functionality. So the track time is a UI component that handles rendering the time in a human-friendly way. So in this case, showing the minutes and seconds in a specific format. So it is an UI widget that expects to receive the time in milliseconds. So first we are locating it and then setting the value as the current track time multiplied by 1000 to set the value in milliseconds. It will take care of all the rest so that we get actual minutes and seconds displayed nicely. This is one example of Koru widgets that help your life as a developer, so you don't have to do everything. You can use our pre-existing widget library for various things. Progress bar is a similar thing. So instead of us having to implement a progress bar, we are simply using a Koru provided one. So we are locating the progress bar from the view, and we are setting the value as the percentage of the currently played part of the song compared to the overall track length. So only 4 lines to update the track time and the progress bar. That was relatively straightforward, simplifying the element and setting the value. The rest of the updates in the overlay, we want to make the view more dynamic, so we are actually setting the attribute fill for the overlay itself, which means that it has a specific color. Our music library provides us with a set of colors per each song, so we are setting the song color from the primary swatch array, and we are also going to update the colors of the gradient rectangle I mentioned just a while ago. So we are not adjusting the gradient rectangle itself. What we are doing is that we are adjusting the animation to attributes so that we are animating towards a specific color from the previous one. So the first animation element we are setting to the primary color, the second animation element we are setting to animate towards the secondary color. And we will be starting the animation with the animate. The highlight means a specific event will trigger the animations. So all the animation elements which have a begin condition of highlight will run. Our gradient rectangle have the 2 animations, and both of them will start when we trigger the highlight. The next part is straightforward, so updating the artist name is simply getting the artist name text and then setting the text buffer attribute according to the music playback artist name. Same thing for the track name. So our UI is also handling its own updates, which means that we need to set a timer to update the UI every 1 second so that we have the time running as well as the progress bar moving. So if the track changed, we need to clear our interval so that we start over. If the track is paused, it's a similar thing. If we are playing, we need to set the interval to tick every 1000 milliseconds. So every 1 second we will need to update using the overlay interval. So whenever the overlay interval is triggered, basically we are incrementing the seconds count by 1 and updating the progress UI, which we covered a while ago. So this, in fact, should now have us updating the UI according to the music player state changes, and we should actually be able to save and test this. So let's now click on the play button. It looks like we connected everything as we should. The time is running, the progress bar is moving, and if we now press the next button, since we have the overlay update whenever the music player is notifying us of change, we should also see the backgrounds changing. And that is actually happening. So now we have our music player implemented. So one last thing I could actually add is the overlay on top. Because we have a round display on this device, let's add an overlay so that we hide out the parts that are not being seen on the physical display. Hopefully this gave a decent introduction to how applications are built with Koru, how we can actually build a relatively complicated UI in a fairly short time, and how well this aligns with the development model seen on web. Thank you. Next, we will be compiling the application and running it on the device. And in order to save some time, we won't look at the actual compilation, but we will cut to the actual application running on the device. And here we have the device flashed with the new software. If we go to the application switcher and launch the installed music application, you can see the familiar UI. And as you can see, the view is running very smooth. The animations are there. And that's basically the application on the device. Next, let's take a connection to the actual development board and see what kind of a performance we are getting out of it. So here we have our own shell, and we can use the get FPS command to get some prints of what is going on with the rendering. So here we can actually see a printout of multiple frames being generated. The blue bars actually represent the DMA transfer when it starts, when it ends. The red represents the Koru part, which we take to actually draw the view, and then the green for flushing the GPU. So at the moment we are seeing 56 frames per second, which is the maximum display refresh rate we have at the development board. So we are maxing that out. In fact, we could do much more if we didn't align with the display sync. We can see that actually drawing the view takes less than 3 milliseconds. So even though this view is fairly complicated, it can be rendered in a very short time. So we are consistently seeing the maximum amount of frames per second, only limited by the display refresh rate and the DMA transfer.